Okay, let's dive into this explainer. We so often view science as just this static list of facts you have to memorize, right? But today, we're going to explore its beautifully complex, totally ever-evolving systems. We're going to challenge your traditional thinking a bit and hopefully help you look at mundane, everyday things with the sharp, inquisitive eyes of a true explorer. So, I want to ask you directly, are you a wise person? Think about how you typically approach learning. Do you prefer just passively taking in a list of facts? Or do you find yourself constantly asking those brilliant, nagging questions about how things actually work? Because we're about to completely flip the rigid idea of science totally on its head. The source material puts it perfectly. It says it is not just a textbook with facts. It is an invitation to question, to perform experiments, and to explore. So the crucial point is that true science is an active, exploratory process. It's a wide-open invitation to look closely at the world, to genuinely test out the materials around you, and to really try to understand the beautiful, complex environment we all live in. Think about it like this. Just as a paper plane glides through the air, learning truly takes flight when curiosity leads the way. And honestly, it's a wonderful reminder of real scientific history. I mean, something as simple as folding and throwing a piece of paper actually inspired massive, world-changing explorations of flight. From early inventors spending hours, literally hours, just observing the mechanics of bird wings, to modern engineers designing supersonic aircraft, the whole dream of flying started with playful curiosity and simple observation. And this brilliantly illustrates the sheer scale of what science covers. The scope of discovery spans from the absolute micro to the stunningly macro. One moment, we might be examining the intricate, tiny cells inside a single green leaf, and in the exact next moment, we're calculating the massive movement of the sun and stars across the entire galaxy. It covers absolutely everything, small, large, near, and far. Now, to manage all this incredible information, we usually break science down into fields, physics, chemistry, biology, and earth sciences. But here is the secret. While they might appear as completely different categories or like separate chapters in a textbook, they are deeply interconnected. They constantly bleed into one another. Discoveries in biology might rely entirely on chemistry. Breakthroughs in physics often inspire totally new questions in earth sciences. They aren't isolated silos at all. They're actually just pieces of the exact same giant puzzle. Let's actually look at how these scientific concepts show up in everyday life. Imagine you spill some food and get a yellow haldi or turmeric stain on a white shirt. We've all been there, right? When you wash it with soap, it suddenly turns this bright, deep red. Now, what you are witnessing isn't just a frustrating laundry day, it's a dynamic chemical reaction happening right before your eyes. By simply asking why that color change happens, you are actively doing chemistry. Here's another amazing everyday connection. Long before the age of digital clocks and smartwatches, early humans needed to track time, and they did it simply by observing the shadows of objects cast by the sun. Watching how those shadows moved and changed length throughout the day, that was a direct link to the massive planetary physics of light and a rotation of our Earth. Mind-blowing, right? Speaking of planetary physics, even the Earth and the Moon cast shadows, and that leads to the breathtaking phenomenon of an eclipse. To really understand the cycle of day and night, we have to grasp how the Earth rotates on its axis and how it orbits the sun alongside the moon. It can honestly make your head spin if you think about it too long, but it's amazing that we humans have the capacity to comprehend and map out such immense cosmic systems. Let's move to Activity 1.1, Question the Answer, and see how this builds. Okay, here is where we initiate a total paradigm shift. Instead of the traditional school model where you're handed a question and expected to provide the correct answer, we're flipping things completely upside down. The source provides an answer. Your job is to invent a curious, creative question that could possibly lead to it. And the golden rule? There are absolutely no wrong questions. You really need to flex your creative muscles here and let your imagination run wild, just like a true scientist working backward from an end result to figure out how the heck it happened. So, for example, if the answer is, just make it half, what is the question? Now, this could be a response to so many different things, like, how do we ensure equal shares of this delicious birthday cake? Or, what should I do? My history essay is way too long. It could even be, how do I fit this giant piece of paper into this tiny envelope? See how versatile it is? It's pretty fun. Let's push that creativity a bit further. The answer is, because the cat's teeth were crooked. Okay, what absurd scenario could possibly lead someone to give this specific response? Maybe, Why did the villain's evil plan to chew through the laser wires fail? Or, why does the neighborhood stray always leave a zigzag pattern on my homework? Next answer, just add some milk. What is the question? Think of everyday situations or completely unexpected ones. How do I calm down a ridiculously spicy curry? What is the secret ingredient to making this potion turn perfectly cloudy? Or perhaps, what should I do with this incredibly dry, boring bowl of cereal? Let your mind just explore all the possibilities. Or take this slightly adventurous one. The answer is, don't panic, I have my towel. What is the question? Could it be, what are we going to do if the intergalactic spaceship gets a leak? Or maybe, how will we survive the sudden torrential downpour at the beach? It's all about finding the exact context that perfectly fits the clue. Now, what's really interesting about this slide is we have a strict constraint. The answer is 42, but no basic math questions like what is 32 plus 10, and no obvious pop culture answer to the universe references allowed. So forcing your brain outside standard pathways, what could the question actually be? How many mismatched socks are currently hiding under my bed? How many times did I literally have to restart my computer today? You know, this entire exercise brings us to the core philosophy of our explainer today. Great scientists don't just answer questions, they ask amazing ones. This is the true spirit of discovery. Literally anyone can be trained to memorize a correct answer, but it takes real curiosity, deep observation, and honestly, a touch of bravery to ask a question that no one else has thought of yet. That is where real breakthroughs happen. And that leads us to a highly memorable mantra. To be a wise person, you must be a wise person. WYS. Keep this little phrase in your back pocket. Whenever you're faced with a mundane task, a strange phenomenon in nature, or even just a difficult moment, remember to look at it closely and just ask why. So, as we wrap up our exploration of the beautifully ever-evolving world of science, I want to leave you with this. What amazing question will you ask today? Really? Look around your home, look at the sky, look at the things you completely take for granted, and let your curiosity take flight. Don't just accept the world as it is. Question it. Keep exploring. Keep asking why. And I'll see you next time.